So, scientific notation. You've seen this in science, and if you don't remember it, you should have paid more attention. But anyway, the whole point of scientific notation is if you have really big numbers or really small numbers, you want to be able to write them without having to write the whole thing. And especially when you're using calculators, they only have so much room on their screens, so they have to be able to write it sometimes using scientific notation. And the reason they call it scientific notation is because the place where you see these really big numbers or these really small numbers is in science a lot of times. And so the reason it's in this chapter is because there's a lot of exponent work. As you've already seen, here's the basic structure of scientific notation. You're going to have one number, one digit, and then you're going to have a decimal place, and then whatever's left is going afterwards. So I'm just going to put 3 lines, but really that could go on for a while. And then it's going to be times 10 to some power. So go ahead and write this part in your notes. Okay, it's really important, only one digit. So, you might want to annotate this, only one digit. Okay, this is the rest of the digits. All right, and so now it's just a matter of, why does this work? What's going on? So let's just see. If we look at an example, let me bring this back down a tiny bit. Okay, if I look at an example, well, that's better, right? Then we don't take up too much room. So let's say I had 2.049 times 10 to the second power. This is really the same thing as 204.9. Now let's look at y. So this guy right here is the y, right? What's 10 squared? I mean, 10 has some cool stuff. I mean, really, you guys, we have a number system that's based on the number 10. This is the 1 spot. This spot is the tens, and so on. And this is really 10 to the 0. This is really 10 to the 1. This is 10 squared. This is 10 to the negative 1. This is 10 to the negative 2. This is 10 to the negative 3. And so when you go 10 squared, what you're saying is, see, 10 squared is just 100. It's a 1 followed by 2 zeros. So think about it. You're taking the number 2, let's just round it down to 2, and you're multiplying it by 100. You're going to make it bigger by 2 decimal places. You're going to make this number bigger. Anytime you multiply by 10 to a positive number, this is 1,000, so you're going to multiply it by 1,000. You're going to make it bigger. And so you're going to make it bigger by the number of places that you go on the decimal. Okay? My biggest digit was on the ones. Now I have to move it 2 spots because I multiplied by 100. I'm going to move it 2 spots over, which means these guys are going to get moved over 2 spots each. This is going to get moved over 2 spots each. So everything's getting moved over 2 spots to make it bigger. And so I don't want you to worry about, do I go to the right? Do I go to the left? Think about, am I making it bigger or am I making it smaller? So let's look at another example. Okay, so let's say I had 14.57 times 10 to the negative 2. Well, 10 to the negative 2, if we follow our exponent rules, 10 to the negative 2 says, hey, I'm taking the 10 and I'm moving it to the bottom. So really, it's 10 squared on the bottom. So really, it's 100 on the bottom. I'm taking it times 1 over 100. You guys, this is the same thing as dividing by 100. If you take something and divide it by 100, you're going to make it smaller, aren't you? So I need to make this number right here smaller by 100, by a division of 100. And that happens to be 2 decimal places because we're in the decimal notation or the decimal number system, right? So I'm going to make it smaller. So think about this. Everything is getting moved 2 places to the right to make it smaller. So this decimal is not going to be here anymore. Where am I going to make it? If I moved it here, by the way, that would make it a big number. I don't want to move it there. I want to move it here 2 places. So I've got 0.1457. I've got a pretty small number. It's a decimal number. Okay, so let's look at a couple more examples here. How about 23.056 times 10 to the 4th? All right, so I'm want to make it bigger or smaller. So we look at our number. We say 10 to the fourth. That's 1 followed by 4 zeros. That's a pretty big number. I'm going to make it bigger. And I'm going to make it bigger by 4 places. So we need to move this 4 places. Technically, we're not moving that. We're moving the number. But visually, you're going to see the decimal goes 4 places. And you'll notice that there is a place that I don't have a number. And whenever we need a number in a place value, just to hold a place, we'll put in a 0. So this is the number 2, 3, 0, 5, 6, 0, and then we get to put a decimal. So this is 230,000, really. Okay, or what if I want a different number? Let's say I have so I've got, oh, that's not even, okay, so how about 7.65 times 10 to the negative 3? So am I making it bigger or smaller? Again, look at this. Is that a bigger or smaller? Well, that's a 1 over 1,000. I'm dividing it by 1,000. I'm going to make it smaller. So where does this decimal have to be if I want it to be smaller? It has to go this way. 3 places. This is only 1, 2, 3. I've got to have 2 zeros, a 7, a 6, and a 5. Okay, so that's really what the number is. What if I wanted to go the other way? What if I wanted to take a number and make it? By the way, let's talk about this here for a second. So if I have the number 34,690, this right here is called standard form. This is probably good for your notes too. Standard form, or sometimes they call it decimal form. Okay, if I write it as 3.469 times 10 to the fourth, this is called scientific notation. Again, this would be an excellent thing to put in your notes. Okay, so what if I'm given it this and I need to come up with this? Basically what you're doing is you're coming up with directions on how to write it back into standard form. Okay, so you're going to write it in scientific notation, and by what you put in scientific notation, you're saying what to do to move it back to standard form. So let's look at this example again. So I had 34,690. Technically, you first want to identify where is your decimal. Technically, since there is no decimal in the number, I'm going to put it at the end. Now, if I want it in scientific notation, I need one number in front of the decimal, then a decimal, then the rest of my number. So that's where I need my decimal to be. So you're looking at this and you're saying, okay, here's my decimal, but technically it's supposed to be there, meaning past this 9 here, right? The next number. So I've got it right here. My number right here is supposed to give it directions on what to do with this decimal. Well, this is the number 3.4. I want it to become bigger, so I need my number to be positive. And I need it to be bigger by how many spots? So I need to go 1, 2, 3, and I actually need one more number, right? Because I'm looking at my decimal being right here, and I'm going 1, 2, 3, 4. So I need it to go 4 so that it becomes bigger. So I need this number to be a positive 4. Okay, so now basically when you're done putting it in scientific notation, someone else should be able to come along and say, okay, what do I need to do to get it to be my original number? I need to move it 4 to the right so that it becomes bigger by 4 decimal places. So let's look at another example. Okay, let's say we have the number 0.000722. All right, I want to write that in scientific notation. So the first thing I have to do is figure out where my decimal goes. So I'm going to put it 7.22 times 10, right? Because I need one number in front of the decimal. So since all these zeros don't really mean anything, I need it to be right here after the 7. Now 7 is a much bigger number than 0.0007. So I need my exponent to make it smaller. Therefore, I know that I need my exponent to be negative. Now, how many negative? That's where we need to count, right? I have the decimal right here, so look over here. The decimal's right after the 7, so if I go back to my original, the decimal's after 7. I need it to go 1, 2, 3, 4 places. So I'm going to put a 4 for my exponent. So it's a negative 4. That way someone can come along and read this and know that the decimal needs to go 4 to the left so that it makes it more small. And that's why it's a negative 4. So you're going to be practicing a bunch of this in class. Make sure you check to make sure they're right before you go on.